In this video, we're going to talk about the difference between a scalar quantity and also a vector quantity. So when you think of these words, what comes to mind? What is the difference between these two terms? A scalar quantity is something that has magnitude only, but a vector quantity has both magnitude and direction. So if you think about the word magnitude, basically it's the size of something or its numerical value. Direction it carries the idea of something traveling in a certain direction, like east, west, north, or south. So here's a question for you. Distance, is it a scalar quantity or is it a vector quantity? So think about it. Distance is a scalar quantity. If a car travels, let's say 5 miles, you don't know in what direction it's going. So that would represent distance. However, let's say if a car travels 5 miles east, so now you have the distance with direction, which is known as displacement. Displacement is a vector quantity because direction is part of displacement, whereas distance, it's a scalar quantity. Now, what about speed? Is speed a scalar quantity or a vector quantity? So let's say if a bus is traveling at 30 miles per hour. Is that a scalar quantity or is that a vector? Well, we don't have direction, so it's a scalar quantity. Now, let's say if the car is moving at 40 miles per hour north. Now we have speed with direction. That is known as velocity. So velocity is a vector, but speed is a scalar quantity. So velocity, we describe it as, let's say, 30 miles per hour east. The 30 miles per hour, that is the magnitude. That's how fast it's moving. It's the numerical value. The direction part of the vector is east. So you got to have those two parts, magnitude and direction, for a quantity to be a vector. If an object is simply traveling at 30 miles per hour with no direction, then we only have magnitude only, which makes it a scalar quantity, not a vector quantity. So if you can apply direction to something, that makes it a vector. If direction cannot be applied to it, then it's a scalar quantity. So here's another example, force. Is force a vector quantity or is it a scalar quantity? You can apply 50 newtons of force east, west, north, or south. So force has direction. You can push an object, you can push a box to the right, you can lift it up, you can push it towards the north direction. So force is a vector quantity. Now what about mass? Which column would you put mass under, the left side or the right side? Can you apply direction to mass? Can you say, I have 100 grams of aluminum metal east or 200 grams of nickel west? You can't apply direction to mass. Therefore, mass is a scalar quantity. How about temperature? Is temperature a scalar quantity or is it a vector quantity? So can you have a temperature of, let's say, 90 degrees Fahrenheit east or 100 degrees Celsius west? Direction is not part of temperature. There's no association. So therefore, temperature is a scalar quantity. It only has magnitude. It doesn't have any direction. The magnitude could be 90 degrees Fahrenheit, 100 degrees Fahrenheit. Of course, 100 is much hotter than 90. But as you can see, temperature, you can only describe it in terms of magnitude only. You can't describe it in terms of direction. You can't say it's 85 degrees Fahrenheit east outside. It just doesn't make sense. Now, what about acceleration? Is acceleration a scalar quantity or is that a vector quantity? Acceleration is a vector quantity. Acceleration tells you how fast your velocity is changing with respect to time. So if you're driving a car has a greater acceleration than a truck. Both a car and a truck can go from 0 to 60 miles per hour, but a car can get to that speed a lot faster than a truck. So a car has more acceleration. Now you can accelerate towards the east, towards the west, north, or south. So direction can be applied to acceleration, which makes acceleration a vector quantity. Now what about volume? Would you describe volume as being scalar or a vector? Can you have 50 liters of water east or 2 gallons of milk west? Direction cannot be applied to volume, so volume is a scalar quantity. So now you know how to distinguish if something is a scalar or a vector quantity. The key is to focus on direction, because both scalar and vector quantities have magnitude, but only vector quantities have direction. So if direction can be applied to something, then that something is a vector. Now, there are different ways to describe a vector. You could say that 100 newtons of force is applied at, let's say, an angle of 30 degrees relative to the x-axis. So you can you could describe a vector by describing it in terms of its magnitude and direction, which the first example illustrates. You can also describe it graphically. So let's say this is the x-axis, this is the y-axis. So we have a force of 100 newtons at an angle of 30 degrees relative to the x-axis. So you can also describe the magnitude and direction graphically. Another way in which you could describe a force is by expressing its components. So you could say its x component is 30 newtons and its y component is 60 newtons. So let's call this fx and fy. In the graph, it looks like this. So let's say the red line is fx, it's 30, and the blue line is fy, which is 60. So it's twice as long. But because both are positive, they're both in quadrant 1. So this is f. The hypotenuse of the right triangle is the actual vector, and this is f of x. It's the x component of f, and this is fy, the y component. So let's say if f of x was negative 40 and fy is 60. Where would you draw this vector? So first you would have to travel 40 units to the left to describe fx, because it's negative. X is negative on the left side. Now fy is positive 60, so you got to go up 60 units. And so f is in quadrant 2. So if you know the components, you can describe the vector. Let's say if f is 200 newtons, but at an angle of 225 degrees. So if you have to graph it, this is 0, 90, 180, and 270. So 225 is in quadrant 3. So the vector is going to be over here. And this is an angle of 225 relative to the x-axis. When dealing with vectors, you might find these equations useful. So the hypotenuse is the actual vector, f. This is f of x, f of y, and the angle theta. Now, if you have the x and y components and you need to find f, you can use this equation. It's based on the Pythagorean theorem. If you need to find the components, you can use this. Fy is f times sine theta. F of x is f times cosine theta. And if you need to find the angle, this is an acute angle between 0 and 90. You can use the arctan or the inverse tangent formula. It's Fy over f of x. And if I was you, just make f of x and f of y positive, and this will give you the reference angle, or the angle between 0 and 90 that's within this triangle. And then you can always adjust the angle based on what quadrant it should be located in. But these four equations can help you to find missing quantities associated with vectors. So that's it for this video. Thanks for watching, and have a great day.